Dr. Babasaheb Ambedkar Open University.
Namaskar dear students and learner of this course. I am Professor Kamesh Rawal. I welcome all of you in the video lecture series of Dr. Babasaheb Ambedkar Open University. Here we are discussing a subject called Fundamentals of Computer and Information Technology, right? In the last session, we have focused on what is actually octal number system and how can we convert any decimal number to octal, right? Along with that, we have also learned how the octal number is suppose given to you, then we can convert it into the decimal as well as a binary number system. Now today we are trying to focusing on hexadecimal number system. So in our today's session, we will see what actually the hexadecimal number system is there, and then we will see a different type of conversion. Let's suppose if any hexa number is given to you, and if you need to convert it into the decimal, right, or octal or into the binary, then what is the procedure that we need to follow? Okay, so here we will see a different type of conversion. We will convert a number from a decimal to hexa, right? We will also consider conversion from hexadecimal to decimal, right? We will also try to convert the hexadecimal number into the binary. We will convert a binary number into the hexadecimal, and similarly hexadecimal to octal and octal to hexadecimal, right? This two thing, right, that we will discuss into the next session, because see we need to work with in a particular or designated time period. So but rest of the conversion that we will discuss into this particular session, right? Okay, so let us start with numbering system. So as we have discussed, we have four type of numbering systems are there. Binary, whose base is 2. Here only two symbols are allowed, 0 and 1, right? The second number system, that is called the octal number system. The base of the octal number system is 8, and here we can use a 8 symbol from 0 to 7, right? We are using in our day-to-day life, that is a decimal number system. The base of the decimal number system is 10, because there are 10 symbols are there which we are using, 0 to 9, right? So 0, 1, 2, 3, 4 up to 9. Total 10 symbols are there. So the base of the decimal number system is 10. Okay, then one more numbering system is there which is called hexadecimal system. Here the base is 16, right? Because to represent a single digit, we can use a 16 different symbols. So if we'll start from 0, so 0 to 9, then 10 will be represented as a 11 will be represented as a B. So let me write here so that you will come to know. If you have 10, so 10 will be represented as a 11 will be represented as a B, 12 will be represented as a C, so C will be represented as 12, 13 will be represented as a D, 14 will be represented as a E, and finally 15 will be represented as F, right? And this thing you need to memorize, right? Okay, so 10, that is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Okay, fine. Now what is hexadecimal number system? So hexadecimal number system is that system in which we can use a 16 different symbol to represent a single digit, right? And because we are allowed to use a 16 different symbol, the base of this particular numbering system is what? It's 16. And what 16 symbols are there? So obviously we will use all the symbols from 0 to 9, right? But afterwards we need to write A, B, C, D, E and F. Okay. Now see, let's suppose if any number is given, for example this 19 is given to you, okay, and you just need to convert it into a hexadecimal number system. So okay, at that time what you need to do is, we need to divide that number by 16. Every time you need to divide that number by 16 unless and until that number will not turn to 0, right? Okay. Now see, whenever we are dividing any number by 16, right, the remainder can be from 0 to 15, right. So, it is possible that if you are dividing a number, any number, let us suppose here there are number is there, for example some number is given, okay, and if you are trying to divide this number by 16, right. So, let us suppose here division is there and here another number will be there, which will be, you know, it is a multiplication of 16 into y, and here what is the possibility of the remainder? Make sure here you can get a 0 remainder, you can get 1 remainder, you can get 2 remainder. Similarly, you can also get a remainder as a 10, remainder as a 11, remainder as a 12. So, from 0 to 15, right, any number can be here, fine. So, whenever we are dividing any number by 16, at that time the remainder should be from 0 to 15, right. Okay. Now, suppose here if you are getting any remainder in a 2 digit like 10 or 11 or 12, at that time you need to use this thing. Suppose if the remainder is 10, you need to write A, okay. If the remainder is 11, then you need to write B. If the remainder is 12, then you need to write C, and so on, right. Let us suppose 19, that is the number which is given to you. This is a decimal number and we need to convert it into the hexadecimal. So, obviously, the base of the hexadecimal is 16. What you need to do is you just need to divide this 19 by 16, and we know that 16 ones are 16. The number is what? It is 19, right. So, here 3 remains. So, I will just write 3 is the remainder, okay. Now, again you just need to divide this 1 by 16. Now, see 1 is a smaller than 16, right. So, here 16 zeros are 0 and the number is 1. So, this 1 will comes here, right, in the remainder section. You just need to write it down the number into this way, okay. So, what we are getting is we are getting 13. So, 13 is what? 13 is the hexadecimal number of decimal 19, right. So, here you just need to write 16, okay. Similarly, let us suppose this 173, right. Let 173 is the decimal number which is given to you and you just have to convert it into the hexadecimal. So, what we will do is we will just divide this 173 decimal with 16. So, here we know that the first 2 digit is what? 17, and that is a bigger than 16. So, I will just start with the 17. 16 ones are 16, but the number is 17. So, 1 is there. So, 1 and 3 will make what? 13, okay. Now, you just see 13 is what? It is a smaller, right. This is a smaller, right, than 16. So, here I will put 0, right. So, it is, you can understand something like this, 16 10 ja 160, but the number is what? 173. So, here 13 is there, right. So, remainder is what? 13, okay. Now, again 16. So, you know, if we are trying to divide this 10 by 16, 16 is already larger than 10, right. So, here 16 zeros are 0 and remainder is what? 10, okay. Now, if you see 10 will be represented as a A. So, here you just need to write A because 2 digit number is there in the remainder, okay. So, 10 will be represented as a A, then 11 it is B, 12 C, 13 is D, right. So, here this 13 is there. So, this 13 you need to write into the single digit and that single digit is nothing, it is a D, right. Now, all the remainders you need to write it down into this way. So, here you know 173, this is the decimal number, and if you want to write it into octal number, you need to write A first and then D, right, A and D. So, this is what? It is a hexadecimal number. So this is a hexadecimal number, so we will mention 16 here, right, because the base of the hexadecimal number is 16, right. So suppose if 173 decimal number is given to you, right, it's a 3-digit number, but when we are converting it into the hexadecimal number, we are getting only 2-digit, right. Okay. So see here, this 1954 and 173 are converted into the hexadecimal number, right. Okay, fine. Now see here, we have already discussed this thing, right. The first column that actually represent what? It is a decimal number. So here we have the decimal number, right. It is something 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right. After 10, what we have is, we have 11 to 20, 21, right. So this is what? It is a decimal number, 22 to 32, right. Okay. If you are writing into the hexa, so here up to 16, right, you have to write a single digit, right. We can use a single digit because there are 16 symbols are there. So here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we are not writing 10 because we have still a few more symbols. So we will 10 will be represented as a, then this 11 will be represented as a B, then C, then D, then E, then F. Now if we are writing F into the hexa, that represent what? 15 decimal. Okay. Now we have completed all 16 symbols, right. When 15 is there, we have used all hexadecimal symbol. So how can we write a 16? So now we need to switch over to the 2-digit number, and that 2-digit is what? 10, right. So 10, 11, 12, 13, 14, 15, then here we have 16, 17, 18, 19, then 1A, 1B, 1C, 1D, 1E, 1F, then 20. So see, in the hexadecimal, if we are writing 20, we are actually reaches at 32 in the decimal. Clear? So this is what actually the hexadecimal number system is. Okay. Now suppose if anybody has given a hexa number to you, and suppose if someone told you that to convert that number into a decimal form, right, what you will do? So see here, there are several examples are there. 46, that is what? 46 is the number given in which format? In the hexa format, okay, and you just need to find out its decimal number. So here we know that the base of the hexadecimal number is a 16, right. Which number is given to you? It is a 46. It's a 2-digit number. So 4 and 6, these are the 2 digits, and because the base of the hexadecimal number system is 16, so you just need to start from 16 raised to 0. So last digit will be multiplied with 16 raised to 0. Second last digit will be multiplied with 16 raised to 1, right. Now we know that any number whose power is 0, that will represent 1. So here we have returned 6 into 1. Okay. Now 16 raised to 1, 16 to the power 1, it is a 16. So we have returned 4 into 16. Now 4 into 16 is what? It's a 64. 6 into 1 is what? It is 6. Okay. So now 64 plus 6, so that is what? 70. Okay. So 70 is what? It is the decimal number of hexa 46. Clear? Now suppose here, the hexa number is given. Now see, whenever the hexa number is given, the examiner can also gives you alphabets like A, B, C, D, E, F, right. Obviously A to F, that can be there, right. Now if here A is given, you just have to understand A means what? It is 10. So I have returned 10. You just have to understand the first digit is equivalent to 10. The second digit is what? 3. So here we have returned 3. And as usual, we will just multiply 3 with 16 raised to 0, and we will multiply this 10 with 16 raised to 1, right. So here 3 into 1, because 16 raised to 0 is 1, 16 raised to 1 is 16. So 16 has to be multiplied with 10, and it will make 160. 3 into 1 is what? It's a 3, right. So 160 plus 3 is what? 163. So 163, it is the decimal number. If you calculate it's a hexadecimal, definitely you will get what? A3. Okay. Here a few more examples are there. The hexa number is given, B and F. So you know B and F both are allowed, right, because we have all symbols ranging from A to F, right, in the case of alphabet. Fine. B, that is 11, you know, A is 10, B is 11, and F is what? It represents 15. Okay. So when B and F is given to you, you just have to understand B is nothing but it's a 11, F is nothing but it's a 15. Now as usual, first digit has to be multiplied with 16 raised to 0, and second digit will be multiplied with 16 raised to 1. So here 15 into 1, because 16 raised to 0 is 1, right. Here 11 into 16, because 16 to the power 1 is 16, right. If you multiply 11 and 16, you will get 176. 15 into 1 is 15. So 191 is what? It is the decimal number of this hexa. Okay. Now here we have taken the example of 3-digit, you know, 3-digit hexa number. So suppose the 3-digit hexa number is given in this way, 2A5. So obviously the first digit 2, so I will just write it down 2 here. The second digit is A, and we know that A is equivalent to 10, right. So here 10 is written. The third digit is 5, so obviously we have mentioned 5 here, right. Now what you need to do is the last digit has to be multiplied with 16 to the power 0. Second last digit will be multiplied with 16 raised to 1, and third last digit, that has to be multiplied with 16 square, right. So here 5 into 1, because 16 to the power 0 is 1, 10 into 16, because 16 to the power 1 is 16, and you know 2 into 256, because 16 square, 16 into 16, that will make 256, right. If you multiply this 256 with 2, you will get 512. 16 into 10, so 160. 5 into 1 is 5. If you are adding all this thing, 512 plus 160 plus 5, you will get 677. So 677 is the decimal number of this octal number, right, 2A5. Okay. Now we will see how can we convert a hexadecimal number to binary and binary number to hexadecimal. So see, in the last session we have seen that in the octal number system we have total 8 symbols, and to represent 8 symbols we need 3 bits, right. Why? Because 2 to the power 3 will make 8, and 8 is what that much symbols are there in the octal number system. But if you want to convert a hexadecimal into the binary, you know, in the hexadecimal system we have total 16 symbols, right. So here 0 to 7, not only that 8, 9, A, B, C, D, E and F, right. 10 will be represented as A, 11 will be represented as B, 12 will be represented as C, 13 will be represented as D, 14 will be represented as E, and 15 will be represented as F. So total 16 symbol we have. Now if we want to represent a single digit of hexadecimal, right, and that can be you know, how much symbol will be there? 16 symbols are there, right, into the binary. Okay, into the binary. So binary base is 2, we are using just 2 symbols, 0 and 1. So what power we need to put? So here we know that 2 raised to 4, that is 2 into 2 into 2 into 2, 4 times, right. So that will make 16. So to represent a single digit of hexadecimal we need a 4 bits of binary. Okay. So 0 will be represented as a 0 0 0 0, 1 will be represented as a 0 0 0 1, 2 will be represented as a 0 0 1 0, and so on, right. Similarly F will be represented as a 1 1 1 1. Okay. Now let's suppose the hexa number is given to you, that is A6. How can we convert this number? In the binary form. So first you just see here what we have is we have A, okay. A means what? 10. So you just check it out, 10 can be written as 1010, okay. So we need to write 1010 here, okay, fine. Similarly, what is the second digit? It is a 6, right. And how can we write 6 in the binary? So here 0 1 1 0, right. So here we have returned 0 1 1 0, okay. And this is what? It is a binary of A6 hexa number. Suppose 2 3 is given to you, okay. So you just need to check it out. What is the binary of 2? It is 00 10. So you just write down 0010, okay. And what is the binary of 3? 0011, okay. Now see, we know that the left hand side zeros are not important, right. So you just delete this. So finally we are getting what? 100011. So this is a binary 100011. It is the binary of 2 3 hexa. Suppose if one more hexa number is given to you, CF16, right. So you just check it out. What is the binary of C? It is 1100, okay. And F, it is 1111, right. This is here, okay. And your binary is ready. Similarly, if any 3 digit number is given, for example 7, you just look the binary of the 7 into the table, you will get 0111, then A is a 10 will be represented as a 1010, and D, right. So D is 13, right. So 13 will be represented as a 1101, right. You just write down the binary, right, and whatever leading zeros are there at the left hand side, you just remove it, right. So you will get the binary. Now see, let's suppose if anybody says you just write down the binary of D, okay. So first you should know the D is what? It represent actually 13, okay. And how can we find it out, a binary of it? So see, D is a hexa number, and to represent the hexa number we need a 4 bit of binary. So this is first bit, second bit, third bit, and fourth bit, okay. Now again 13, right, we need to bring what? 13. Now here you just need to start from 1. What is the double of 1? It is 2. What is the double of 2? It is 4. What is the double of 4? 8. So you just need to write it down in this way, okay. Now this is 13, right. So 13 is a bigger than 8, okay. So you just take 8, right. So once we have taken 8, means you need to subtract this 8 from 13. So how many is remain? Now we have taken or considered 8. So we'll subtract 8 from 13. So we have 5, okay. Now 5 is what? It is again a bigger than 4, okay. So you just need to consider this 4 too, right. Now if you have considered this 8 and 4, 12 is there, right. If you have considered this 4, what number we have at last? It was 5. Now if you are considering this 4, so 5 minus 4, so now what thing is remain? 1 is remain, okay. So now only 1 is remain, fine. Now 1 is a number that you need to bring. Here what you have is 2, but 2 it is a bigger than 1, so we cannot consider this 2. So here I will put 0, okay. Now here 1 is there, yes, we will consider 1, so that this 1 will be considered, right. So 1 minus 1, that number will becomes a 0, and this is what? 1 1 0 1, right. This is a binary of D, 13, right. So by this way you can make a binary your own, right. Suppose if you are not be able to memorize the whole table, this is the technique, okay. Now you just practice it, this thing, right. Try to find out a binary of E, A, 9 and so on, okay. Fine, let suppose if the binary is given to you and you need to convert it into the octal, right. So, we know that if we want to represent any hexadecimal number, then we need a pair of 4 bits, right. So, whenever a binary number is given to you, what you need to do is from the right hand side you just count 4 bits. So, this will be 0 1 1 0. Now, you just find out 0 1 1 0, 0 1 1 0, it is this, okay. So, that is representing what? 6, okay. Now, here what you have is you have 1 0, right. So, this is just 2 digits. So, what we will do is we will append to 0 here to make a pair of 4 bits, right. So, now my number will be 0 0 1 0. Now, you just check it out 0 0 1 0, it is what? 0 0 1 0, it is here, and this is 2, okay. So, you just mention 2 here. So, 26, it is what? It is the hexa number, okay. Now, again the second example, here try to make a pair of 4 bits. So, this 1 1 0 0, so that 0 0 1 1 we have written here, and rest of the thing, that is 1 0 1 0, that you mention it here. Now, we know that 1 0 1 0 will represent A, and this will represent what? 1 plus 2, so it will make 3, okay. Another number is given to you. So, here this 4 bits we are considering here 1 1 1 0, right. Here only 2 bits are there 1 1. So, we will put 2 more 0 at the left hand side. So, we will write 0 0 1 1, right, and the another number is 1 1 0. Now, this is what? You just check it out. What we have is we have 1 1 1 and 0. So, 1 is not there, 2 is there, 4 is there, and 8 is there. So, 8 plus 4 plus 2, okay. So, that is what? 14, and 14 is what? It is E, okay. Similarly, 0 0 1 1, okay. So, here 1 is there, 2 is there, 4 and 8 is not there, right. So, 1 plus 2, so that will make what? 3, okay, because the first bit is 1, second bit is 2, third bit is 4, fourth bit is 8, right, okay. So, in that way you just try to compute a hexa of this binary, right, okay. So, in this session basically we have focused on few conversions, right. We have seen how the decimal number has to be converted into the hexa and how the hexa number will be converted into the decimal. Not only that, we have also seen how can we convert a hexa number into the binary and binary number into the hexa by making a pair of 4 bits, right. Still there is one more conversion is there, right. We will see in the next video session how a hexa number is given to you, then you can convert it into the octal, or suppose if the octal number is given to you and you want to convert it into the hexadecimal, then what procedure that we need to follow, right. Fine. So, we will meet in the next session and we will do a further discussion. Till then, take care and bye bye.